Question 9. So we're gonna do question 9 here. And also note that we do not all of the questions, some items I miss, so you can do it by yourself. One of the most important notions that you will be expert of the computer science, but you might lose it, you might not remember it. It's the function. Function is the special relation on A times B on the so it's a relation, but it has a feature. What's that feature? So function is a relation that the machine is functioning well. Okay, so the way that I'm talking about this, it's coming back from my experience. For example, if you've got the laptop and if you press it like a button on laptop, if it functions like so, if you press F, it should give you it should type or print F. Okay, but if you press F one time, it gives you F. Then next time it gives you S. It means your keyboard has got a problem. Okay, so it means your laptop is not functioning properly. So, for example, okay, so I press F, it gives me sometimes F, and it gives me sometimes S. Okay, so I've got one input, but several output, several corresponding output. It means it's not functioning. Here is the definition. A, B1, A, B2. So if I have this one, B1 and B2 should be the same. Here, F, Fs, it's not the same. Okay, so this is not the definition of the function. And the first condition of the function is this: whole of the buttons, whole of the inputs, they should work. Okay, I shouldn't have any button on my laptop that doesn't work. It's not acceptable. It means my relation is not functioning properly. Now, whole of the buttons, press, mouse, whatever, like the input can come from my voice as well. They are called domain A. So the relation that this relation should have all the members of the first set A here. Okay. Codomain is the possible outputs, but my possible outputs should not be whole of the B. It can be a subset of B. Okay, it is okay. Okay, it depends on the price of your laptop, for example, and the range is the really price of your laptop. So it means a subset of the B. It means whole possible of output in B. Okay. If this range is equal to whole B, so your laptop is good. It's surjective. It's covering B. Okay. If the range is equal to the codomain, your function is also, your relation is not only function, but also it's onto, or in other words, it is surjective. Now, here's the thing. Like if for any corresponding output, if we have only one input, okay, like if I press one button, BT1, BT2, print, and if I press BT2 second button, it also print. It is function. It might be surjective, but it's the buttons, they are not working injectively. It's the relation is not one-to-one. So we will see more in the example. Here, every button gives me just a unique output. The 2 also gives me 1. So it means it is functioning properly. It covers whole codomain. The range is equal codomain. So it means surjective. And also it is one-to-one relation. Okay, for example, it's not like this. Okay, you can like maybe different buttons do the same job. Okay, you say that it's the same job. Yeah, several buttons do the same job, so it's just, the company is just built this to like it's not one-to-one. Here H, what is H? Is H is functioning properly? No. Sometimes it gives me 2, sometimes it gives me 1. Okay, so the programming is not right here. This one, 1, 2. You have seen that some of the toys, they've got several buttons, but they do the same job. It is like this. So it's not one-to-one relation. K. This K is not surjective. It's one-to-one, it's function, but it's not surjective because 2 is not in the range of function K. We cannot have this output. We don't have it. Not we cannot. We don't have. Now, I is not an injective because it is like this. I is not functioning properly because it is like this. But it can be surjective. But usually we talk about surjectivity, injectivity when it is function. But a relation can be surjective. So this is a just relation, but it's not it's not a function, it's not surjective. So this relation is just complete is a two-parted complete graph. So it's all of that. Okay, so G is the function, not one-to-one, not onto or surjective. And you can do this one as well, although I told without writing. Question 10. One of the following is the function and one is not. Which one is the function? Okay, so we see that here Ali is to this one 5, 5, 5. Okay, so this is have a look at here, A times B, and this one is the, okay, are you listening? A times B, and this is a relation which is subset of this one. So Ali gives me sometimes this number to me, and sometimes it gives me this one. So Ali is like maybe fooling us. Okay, so it's not fun. He or she is not functioning. For example, but you can see this one. This one is Ali to this one 5, 5, 5, 1, 2, 3. This Isabella is this 4, 5, 6. So this is simple example, but I prefer to do it in this way, so it is easy to understand whether it is function or not. Sometimes to do this part is not easy. Okay, so let's do this one. One-to-one, here's the thing of the one-to-one here. So we see that one-to-one, it's not one-to-one, it is one-to-one, not one-to-one. Now, if I have a function 2, injectivity or one-to-one, 3, onto or surjectivity, okay, then we say that an f is from A to B. It means f is a relation such that it is A times B. Okay, so this means my f, there is a bijectivity. I said bijective, it's not right. There is a bijection or bijectivity from A to B. Or I can say that A is equivalent with B. All right. Now, algebraically is this one, the function, one-to-one. So for function, do you remember these things from your high school? X1 equal X2, then f of X1 must be f of X2. So one-to-one, you should have f of X1. If f of X1 equal to X2, you should be able to imply that X1 is equal X2. So, but question 12. So you can understand K is not surjective here. So this guy is not, there is not bijection from here to here. In the bijection as well, the cardinality of A must be equal to the cardinality of B. Now, question 12, I'm telling that if P1 f of X1 is equal f of X2, then it is like right arrow, but it is valid. X1 is X2. So if this one is P, then Q. What's the contrapositive for this? It is, yes, excellent, not Q goes to not P. Now, from here, you see that. So this means P, this is the Q. So not Q is A1 is not equal A2. Then this guy here, f of A1 is not equal to f of A2. So which one is easier to do in the one-to-one? This one. So for function, but for the function, this one is better. So we start from x1, x2, then f of x1. So this part is easy. For one-to-one, this one is easy. Contrapositive version. Now, a relation, if it's function and if it is one-to-one, then its inverse will be also a function. But a relation can be can have an inverse, whether it is function or not. We don't care. So the inverse, it's a f, let f is the function and it's a subset of A times B in injective. So one-to-one. So its inverse will be also function. But if it is relation, so we can still have the relation, but it might not be function. Definitely, it won't be a function. So having this one in the mind, so can I write something more? I'm just moving fast, so which I shouldn't do that. So let's do C. B, so we discussed a lot. B, f from natural numbers to the natural numbers is this. F of n equal to 2n. So if I know that I should do this one, but I like to do this one. What is this? N1 is not equal N2, but it is easy for me. F of N1 is not equal to f of N2. Why? Because 2N1 If I've got this one, 2 and 1 can't be. With multiplication, it won't be equal. If I wanna do this one in this way, f of n1 is equal f n2, which is equivalent to say that 2n1 is 2n2. From here, if I divide or multiply by 1/2, I will have n1 or n2. So f is 1 to 1. But this is the easy one, but it's not easy as always. So best way is to do the contrapositive version. Question 13, we can talk about the compositions. So you've got this one, and from question 11, 1 goes to 2, 2 goes to 1, and I see that f of what is g, and g is this one. This is f, and it is g. G is 1 goes to 1, 2 goes to 1, and there is a 2 living here. So I can write f of g of x. I want to have this one. So one thing, f is 1 to 1. So f has inverse. G is not 1 to 1. So G is not invertible. Okay. So now regarding this one, now I want to solve this equation, this question. So I just mixed the question. So when I saw this, I thought that I will do question 13. So question 14, f of f o g like 1 is this. F of, have you seen the compositions of the functions f o g? No? F of g1. So what is g1 doing to this one? Okay, so g takes 1 to the 1. So f of, so instead of here, I will write 1. So f of 1 is 2. F o g. So the domain of the x, f o g, should be the domain of and range of f should be subset of the domain of g. So range of the first one should be the subset of the domain. So range of f o g, what is that? Okay. Range of g is 1. Codomain is 1, 2. Range of g is 1, and it is subset of f, this one. So it is possible to define f o j x. So this one is f of g2. So from here, what is f of go2? This is g. 1, 2. G takes 1 to the 1. F of 1 is 2. So this one come for the none of that. Okay. Now Here is the thing. So we were able to define FOG X because domain range of G is just one, which is just subset of F, domain of which is 1, 2. If we don't have the range of the first function is not subset of the domain of the second function, we are unable to define FOG. So F let's say 1 to 2 to 1 1, and what's the K? 1 goes to 1, 2 goes to 3, and 2 is living here. Okay, so FOK X. Can we define this? Do they exist? Range of, what is the range of K? What is the range of K? Range of K here. What outputs can K get? Yeah, so when I said output in the computer science language, so you understand me better. Is this subset of the domain of F? What is the domain of F? 1 and what are the inputs of the F? Yeah, 1, 2. Is this okay? Subset? Is this subset of this one? So then I am unable to define FOK. Okay, so it's not, it won't work. All right, so let's see this one. Now, so let's quickly just do this with different colors. Is this function A equal A, but A sometimes gives me 1, sometimes gives me 2. Is this function? No, it's not function. So, but this is one way to do this. So other way is this. A to goes to 1, A goes to 2. What are the range of the B is this one. It has 3 and way. So number 1, A is not function. A is injective. A is not surjective because this relation is not surjective. But anyway, usually when it's not function, we are not talking about injectivity and surjectivity. Okay. Let's do this one. F from B to B. I'm talking about this one here. So 1, 1, what is the one? B is 1, 2, 3. What is the domain of B? 1, 2, 3. 1 goes to here to 3. 2 goes to 2. 3 goes to 1. It is functioning properly. It is surjective because we don't have something like this. Okay, A, B, like C. We don't have something like this. And it is surjective because it covers whole codomain, because range is equal to the codomain. And you can do D and E. I'm not sure if you will have D and E this here. This one. Is this bijective? Let's see. X1 equal X2. So 2x1 plus 1, 2x2 plus 1. I added 1 to the both sides of the equation and I multiply both sides of the equation. Then I add by 1. So it is f of x1 is equal to f of x2. So it's function. F of x1 is equal to f of x2. So from here, 2x1 plus 1 equal to 2x2 plus 1. From here, we can cancel these and then cancel, divide by 2. Okay, so cancel, cancel, different color, cancel, cancel. So x1 is x2. So it is 1 to 1. Okay. How to do it algebraically? Surjectivity is this one. Let a y belongs to R in the codomain of F. So yeah, this is a y. So if I can find a and x belongs to F from R to R from here, so such that f of x is y, then f is surjective or onto. But fx is equal y. I should have this one. I should have this one. But fx is equal to x plus 1 equal y. From here, I should find x. I should find x. I can find an x such that this guy. If I find x, then this will be hold and this will be like okay. So we will be able to say that f is surjective. So from here, x is y minus 1 divided by 2. So if I have f of y minus 1 over 2, then I will have y, because 2 times y minus 1 divided by 2 plus 1. If I simplify it, I will get y. So I found the corresponding of y like this here. So f is surjective. Okay, so let's pause this one.